What's going on, guys? Welcome back. My name is Brandon. We've got a really fun episode today. I'm going to show you how to build aluminum race cabinets at the fraction of the cost of new. And as with anything, guys, there's dozens of ways you could do this. This is just how I'm going to do this, but I'm showing you an easy way to do it. I'm going to show you the prices all along the way. It's just an affordable alternative to buying regular race cabinets that cost thousands of dollars. This is what we're going to be building, guys. We're going to be building this lower set of cabinets. This is at the front of an enclosed trailer. Then we're also going to be building these upper cabinets here. Probably looks pretty complicated. We're going to do this all out of aluminum. And the great part about this, guys, is that you don't need to go out and buy a specific TIG welder. If you've got a MIG welder and you've got some argon gas, you can actually weld aluminum. I have a video showing you exactly how to convert any welder that MIG welds aluminum that can accept a gas on how to do that, and I'll put a link up above. We're going to try to make this real quick today, guys, because we are having a storm right now. It's raining, slushy, messy. So this is my enclosed. It's 7.5 wide, 16 foot long. It's a Neo all aluminum trailer. This is going to be my mobile workshop slash toy hauler. So here we are, guys. This is at the front of the trailer right here. Okay, you see you got storage all the way back there. We still got a lot to do in this trailer to be finishing it up, but for today we're just going to be focusing on these cabinets, guys. Now what this is going to boil down to simplify this, basically is going to be a bulkhead. Just picture us building this section of cabinets right here. So you got a door. These drawers are actually this cabinet. Just picked this up super cheap. It's a Craftsman. It's going to work perfect for what we're trying to do here. This is all an aluminum frame all around here. So the first thing we started out doing is getting a measurement from inside here to inside here. And I'm making it about 1/8 of an inch smaller in width, just so we don't have to force it in. And you can see we've got a little lip right here, and then this is going to extend back into this area here. That's going to be a piece of cake. So this bulkhead is going to be pretty much right about in here. So then there'll be a wooden cleat along the wall and along there, and that's what the bench will attach down to. This is going to be really slick, and it shouldn't take a lot of time, guys, and you should be able to get real professional results. So once I had a general idea of what I was looking to build, then I went and kind of sketched it out. Now I got a height, so the base cabinets are going to be 38 inches tall. So overall from the floor to the top of the work surface, it's going to be 38 inches. Then I went and measured the inside dimensions of the trailer. These are all going to vary according to your trailer, but you're going to build these the same way regardless of whether it's a 6 foot wide trailer, 7 or 7.5 or 8 or whatever it happens to be. This is going to be a really simple way that you guys can do this and end up with professional results. From here to here, I already have that measurement. It's going to be 80.5, and I already know that I want them 38 inches tall. So the next thing I did is I drew up a sketch of how I was going to do that. So I measured the toolbox and the toolbox width. So the way this is going to work is I'm going to have a vertical upright against the side here. Be another vertical upright against this side. Then I know the width of my toolbox, so that vertical right there will butt to the side of the toolbox, and the other vertical will butt to that size. Whatever is left over for this width right here, that's going to be the door. And the way we're going to build the doors is I'm just going to build an aluminum frame that fits inside our aluminum opening here, and then I'm just going to skin it with some black aluminum. And then we're going to put some thin wall angled aluminum around the perimeter, so it almost like picture frames it a little bit, probably like 3/4 of an inch wide all the way around, just so you don't have a sharp edge on this. We do the same locks and everything. This is going to look incredible. I want the toolbox up to the top here, so we're going to have to build a little, basically like a riser up underneath the toolbox, because at some point I or somebody else who buys this trailer down the road may want to put like a winch underneath the toolbox. It'd be a good place for that. It's got a removable compartment right here to be able to get to that. Or you might want to put like a diesel heater or an electric heater or whatever. So this is going to be my welding trailer slash motorcycle trailer. So inside these cabinets, I need to be able to store like grinders, my metal chop saw, a couple welders. I want this up here to be big enough to fit like welding hoods and motorcycle helmets. So it's kind of going to be a dual purpose trailer. And for materials, I'm going to be using 1 inch by 1 inch by 1/8 inch square tube. And as I do this entire project, I am going to give you prices on exactly what everything costs, right down to the dollar of what I'm paying, including the toolbox. I ordered way more aluminum than what I actually need. They come in 24-foot lengths, and I bought 3 lengths of that material, and it came to $204. The toolbox was like 160 bucks, and I got that for just about half price because it had some scratches on the top, which you'll never see because it's going to be buried inside of this. So now that you know the concept behind this and kind of my thought process of how I'm going about building it, now it's only left to build it. And this could work anywhere, guys. Like I say, if you got a 6-foot trailer or an 8-foot wide trailer, or even an area or a space within your workshop, say something like this. You could put cabinets underneath your workbench. This could take a stainless steel thin top, wrap this top, and then put those aluminum fronts on that. How great would that look, guys? So learning this skill doesn't just apply to an enclosed trailer. You could do it for a lot of things. We're just going to use it on an enclosed trailer today. So with that said, let's get to building. I just want to show you real quick, guys, because I told you that I converted a MIG welder to be able to weld aluminum projects. Well, look, this is what I did with that. This is just literally a 120 volt Hobart handler 140. And yeah, I mean, that's a nice weld. There was really very little practice at all when I did this, and I did a little bit more on this side, just messing around, trying to do 2 stacks of it. That was a little bit earlier, but this one came out much better. So, you know, if you've already got something, you can achieve awesome results, guys, with what you already have. You don't have to go and buy a dedicated TIG welder to do this. So go check out that video. I think you'll find it interesting because that's how we're going to be doing it today. We're going to be MIG welding aluminum. So should look pretty much like this, and that's acceptable. The only difference between this drawing and what we are going to do is that I'm going to have a horizontal top piece and a horizontal bottom piece, as you can see right here. And the reason for that is if you look at this picture, these doors, the bottom of the door is close to the floor of the trailer, and I don't want to have to worry about if I get a little something on the floor, something gets dropped on the floor, or a pebble or a rock, and you go to open the door up, and then it ends up scratching the face of the door. So by me lifting it up an inch off the floor, that's going to give the door an inch of space underneath it. So what we're going to do is we've got to have 2 pieces at 80.5 for the top and bottom that are going to run left and right. And then we're going to need 1, 2, 3, 4 of these verticals at 36 inches. One of the first things I want to do, guys, is remove the metal cutting blade on my metal cutting chop saw and swap this out for an aluminum blade. This would work on aluminum, but you're just going to get better cuts, and the blade is going to last longer because it's designed for it. It's made to cut aluminum. This will cut steel and aluminum, but it's not specifically designed to do that. Swap it over to this, and for those of you that don't know, you can cut aluminum using a regular carbide blade, even on like your skill saw, but having a dedicated blade to cut aluminum, you're going to get a better cut. This is a 80 tooth blade versus the metal cutting blade, which is a 66 tooth. First thing we got to do is at least make sure that the ends, or at least one end of it, is square, because you can't just assume that the factory cut it square, or that the place where you had it cut in half also cut it square. This end's good, so now I can measure back my 80.5 inches. The way I prefer to mark things, guys, is I like to use a scribe and just scribe into the metal. Make a mark at 80.5. Then I take a square and line it up to that mark and scribe it in. And then that gives me a nice crisp line to cut by. Then I'm not worrying about cutting to either end of like a mark for a marker. It's an exact line that I need to cut on. And while I'm right here, I might as well measure up the other side and do one of my 36-inch uprights. I've already checked the other end for square. Put my scribe right on 36 and slide my square up to it. You can actually feel the tip of the scribe fall into the line you just made. Then you can just bump your square over to it and scribe a line. And now you have a nice crisp cut line. Another handy thing to have too, guys, if you're getting a little bit older, is to have a set of readers. And these are 1.5 powered readers that I'm wearing, and it just helps you see really clear to get some nice precise alignment. Then you're going to want to have on some safety glasses and some hearing protection, because this is super loud, and just slowly make your cut. Look at that, guys. Nice, clean, burr-free cut. No heat. Looks awesome. An old saying, guys, is measure twice, cut once. And that served me well. This is where it starts to get fun, guys, because we use our layout table, our fixture table, to actually lay all this out and get our 90-degree points so we can weld this thing up. You want to see how I built this? I built this using a template and a jig, and it just allows for standard 5/8 dowel pins and clamps and all kinds of accessories that you can buy over the counter. However, I built all this stuff that you see here. This right here is just a simple 5/8 shoulder bolt that fits snugly down through these holes that were drilled in this table. So I'll show you how this works. So we're going to put a pin there, and we're going to put a pin there. Then we're going to take our material and bump it right into those pins. Grab one of our clamps and clamp it down to the table, just like that. We'll put another pin over here and another pin over here, and we will throw one of our 36-inch pieces up on this side. Wow, I got that close, didn't I, guys? Huh? So just like that, and put another clamp over here like this. That is ready to be welded. However, we got to clean the joints up a little bit, but this makes a perfect 90-degree corner. To clean off this aluminum, we're going to use a stainless steel brush that is specifically only used on aluminum. And the reason for that is that there has an oxide layer on top of aluminum. The oxide layer melts at a much higher temperature than the aluminum itself. So if you don't remove this layer of oxide that's on top of the aluminum, it's just going to make for a real big mess. And the easiest way to do that is just mechanically remove it by using one of these brushes. It doesn't take a lot. We're also going to wash it down with some acetone as well. Then we'll get the ends of this. These clamps will make some witness marks on the aluminum, and if that's a concern, you can always put a little block between it or a piece of a milk jug. That'll help that, but we're going to wipe this down when we're all done with some Scotch-Brite, and I'm going to put a clear coat on it just to help protect it so it doesn't oxide. Alright guys, I just been padding some beads, and we're going to use a spool gun for this week's episode. You could easily feed this through a MIG gun with a MIG gun liner. And you can see that's what I've done here with this, and I use this Hobart handler to do this. And all I did is change out the liner, and this is just a standard 120 volt machine, and I think this did one heck of a good job for a 120 volt machine welding 1/8 inch aluminum. So you could easily do that for this, but we're going to use a spool gun. The material I'm using is a little thicker than I'd like it to be. It's 3/64 wire 4043, and these are my settings: 15.1 volts, 60 amps, and you can see right there I'm using 45 thousandths wire. It's on synergic mode right now. I've been messing with different settings, and I kind of went with synergic. I started out with manual, and my manual settings weren't quite the way I wanted them, so I kind of want to try it in synergic, and then I can fine tune it from there. The issue that I'm having is why I can't get my settings just right is because this is 1/8 inch material and I really wanted to use 30 thousandths wire, but I haven't been able to find locally any 30 thousandths 4043. 4043 wets in a little bit better. 5356 is good. It's a little bit stiffer, a little bit harder to work with, that's all. So I opted with the wire that's a little bit thicker, but easier to work with. I just wish I could find this in 30 thousandths, but it is what it is. So what I did is I notched this joint back a little bit because this is going to be the face of the cabinet right here, okay? So this joint right here, I'm going to weld, but then I'm going to grind it flush. The inside ones I won't have to, and it won't matter. The one in here, this is where the door will be, and the one on the back side, you won't see it, so I'm not going to grind it. But I want the front of it flush, so it's smooth, so this will be ground. Kind of like the thing that I skipped over is kind of what I wanted to say about the material wire thicknesses versus material thickness is you kind of want, when you do an aluminum MIG, to be into like spray transfer mode, and that doesn't really occur until you're up like around 19 volts. Well, the problem being is when I'm up that high around 19 volts, it's actually blowing a hole through the 1/8 inch material. So what I'm having to do is be in a lower voltage, so that's why the 15 volts, 60 amps. You want to make sure you're wearing a respirator when you're working with aluminum. The fumes are really toxic. Welding on this plate right here resulted in a lot different results than that. That's a little more proud than I would like it, so I'm actually going to increase the amperage a little bit. That was much better. Way better. That might be just a little hot. That was a little bit better, guys. This will be the inside of the cabinet, so I'm not going to grind the weld off. I'll just brush this. Now we're at 18.6 volts, 68 amps. So we're good there. Got to work on filling my crater a little bit at the end. You can see a little bit of a crater at the end I got to take care of. Yep, we're gaining, guys. This is coming out good. So I know what to leave and what to grind. We'll mark it left, then we'll say inside. And I'll just stand this up and we'll get that right there. And this is how you do it, guys, when you have a small fixture table and you got something that's a little bit bigger. You know that this is flat and this is flat. If it's making a flat 90 degree, it's going to stay flat. It doesn't matter that that end over there isn't supported. This side, as long as it's welded up good, is going to remain flat. So that's how I do it. Alright, so we're all welded up. I actually brought it out to the trailer to make sure that this fit in between the walls, fit perfectly. I didn't have to like force it in or anything. Had about, just like I planned, just a little bit of a gap on the sides, and we're going to cover that with just a piece of like a little piece of aluminum. So we just didn't want to have to force it in there. So it's all welded up, the perimeter. Now we've got to put in these pieces right here. So the toolbox is 26 3/4. That's exact. Well, it's actually 26 5/8. So I'm going to make the opening 1/8 of an inch bigger, so that the toolbox, we don't have to obviously beat it in to get it into the toolbox. So what I did is I found center of this and then figured out that half of 26 3/4 is 13 3/8. So then I went over 13 3/8 from center, made a mark, and then I actually scribed it underneath. Then I took a measurement from that outside edge to here, and then just transferred that same thing from there down to here and scribed a mark also. Then I just took my 2 remaining pieces and put a bevel on it, both ends, top and bottom. We'll get these welded in, and then we'll have to figure out what we need to make for aluminum to lift the toolbox up so that the top of the box fits under this, and the bottom of the box is up in the air. So we're going to have to build some sort of frame that the toolbox will set on. I've just got some scrap aluminum, and I'm just using a little clamp just to hold that onto my scribe line, so it keeps it good this way and that way and that way. Then I'll weld this, that side, and then I'll lay them flat and do the fronts and the backs, and then grind those flush. I may even make these flush. I don't know. I'm not sure. I'm just wondering if I want to do that for the doors, so that the doors can fit a little bit tighter. If not, I'll have to like clip the corners a little bit on the door. I don't know. I'll figure it out as I go, I guess. That's how I do most of this stuff. Look what happened. I hit that. Couldn't figure out why I was having feeding issues. That's why. I bumped this, and it loosened that up, that feed wheel. I've got the toolbox in the shop now, and as you can see, I've stood the bulkhead or the frame up, and now the toolbox is upside down. So this is how it'll sit. This will be obviously the top, and this is the bottom. Now the reason I'm doing this way is so I'm not working upside down. I can build all the pieces that I need that this has to rest on, and I can do it comfortably. So the first thing I'm going to do is take off the wheels, and I'm actually going to use these mounting points somehow to incorporate these mounting points into bolting the toolbox down. Now, like I said, you got to remember, we've got to be able to, if need be, pull this toolbox out with not a lot of effort. And the reason I need to be able to do that, because in behind this toolbox, and I think we could even get to it through the side doors, there's going to be a battery back there, the 12-volt battery that's going to run everything in the trailer. Plus, you also have all the connections right at the V-nose of the trailer where they come in and they feed all the accessories and where all the wires are run for all the lights. So we've got to be able to pull this out without not a lot of effort, so we could get to those connections if we ever had to. And I want to make it nice and simple. Basically reach in, unscrew a couple bolts, and the toolbox will slide right out. So what I'm going to do right now is get these feet off and try to figure out a way that we're going to mount all this together and make it one piece mount. Still got it upside down, and I think I've got it all figured out, guys, because I can't have it so tight that I got to beat it in and reef it out. It needs to come in and out easily. So the easiest way to do this, and it'll make more sense as we get going, is I've created a frame. The hard part is it's got this lip around it. If it didn't have this lip, I probably wouldn't have to do it. But I'm going to create this frame all the way around it. Then I'm going to tack in these flat plate right here. And what that'll do is that flat plate will allow me to get a couple screws to hold this down to the toolbox. So all the strength is kind of like on the outside of this toolbox holding down. The weight of the toolbox is going to be resting on this right here, close to the outside, versus kind of like more on the inside where it's a little easier to bend. So this frame I'm going to weld up and then put a bolt here and here, here and here, and then I'll be able to slide this in and out real easy without a lot of effort. I'm going to take all this apart, push this toolbox back, and then set all these pieces and parts up on my fixture table. And I'll just move the toolbox back, and I'll cover it up with a fireproof blanket just so I don't get it all covered with sparks. For the sake of speed, I didn't show you me making this, but I'm sure you guys can see how I did it. I just don't want it to drag along forever. But probably the point that I needed to make is that you orient stuff the way you want it to go, and you make notes. So like here, this is the front, and I had it say up, so I know how this goes. So this will sit on here like that, just like that. Now you can see how it's a real tight fit. There's no gaps or anything. It just fits down in there nicely. And now I just got to put my holes down in there, and there's no real easy way to do it with the tools that I have, but they do make something that threads into this. I could actually probably make one myself, thread one in it, and then instead of a bolt head, it's actually a point. Actually, you know what? Let's make one. We'll make one. Yeah, let's make one of those. These are some handy fabrication tips that you guys can just kind of pick up along the way. So here's one of the bolts. This is one that held on those wheels. And I'll just come over to my bandsaw stand. I made this. If you guys want to check it out, I'll have a video. Cut the head off. Just like that. So I'll put this in a drill, just like this. Now we don't want this spinning too much on the drill because I don't want to chew up the threads and mess it all up. Now I'm going to come over to the grinder and I'm going to put a point on this just by grinding it. See that, guys? Nice sharp point. That'd stab you right there. And it wouldn't be too hard to figure out where this had to go, guys. I could actually do the measurement to figure it out, but I just kind of want to show you guys some fabrication tips. So now we take this point piece that we just made and thread it into this. Okay, so I got that threaded in my hand. Bring that over right where it's got to go, just like that, and give it a little tap with a hammer. You can see it right down in there. See that? Watch. Now that made that mark right there. See that right there, guys? That's what that piece made right there. Now we just got to drill that. And if I wanted to get it a little more clearer or crisp so I can see it to drill it, we'll just follow it in behind it with a center punch. There. Might take a couple of minutes longer, guys, to make these little things, but if it ends up being right the first time, and you don't have to come back and do it again because your hole's off, then it was worth it, right? And for this, guys, I'm going to use my mag drill that I converted over and made it into a drill vise, and it is super handy for doing stuff just like this. I use this all the time. I don't necessarily have a use for a mag drill, but I do have a use for a drill like this, and this thing has tons of torque. And the great thing is you can run annular cutters on this, you can run hole saws, it's incredible. Chamfer on it with a chamfering bit. Now, if we did everything right, yup, look at that. Everything should be lining right up perfectly. And it does. So I guess we did okay. Get an impact, we'll tighten these down. Not going to need a lot of tension. There. That's nice and rugged now. Perfect. Guys, I'm outgrowing my workshop something wicked. I gotta do a cross piece right here, and then we gotta start building the supports that hold this up, because right now this is upside down. So you can see how if I pulled this out, I've got to just make this easy, like I said, to come out. So I got to cut a cross piece, but as you can see, my bench is completely occupied right now. I've got my saw buried back here now. Don't really have another place to do it. I'm going to have to make this piece like a rough length, which is like 27, and then I'll bring it back to my saw to cut it. These are some of the disadvantages of having a cramped, small workshop. But there's a way around that. Remember earlier I was telling you that you can use a skill saw to cut aluminum? Well, this is actually a skill saw. It's actually a track saw. We're going to be using this later in the episode, probably in like part 2 or 3. We got to cut some aluminum sheet. But this saw we're going to use to cut that. This is a combination. It does mild steel, aluminum, wood, and plastic. So this is a pretty awesome blade. So what I'm going to do is I'm going to use this to cut that to rough length, and then I can get it over to the chop saw to get a nice straight cut. In case you can't tell, guys, I love Evolution tools. So I've got a lot of them, and I love them. They're just good tools at a reasonable price. Here we go. Watch how good this works, guys. Just like cutting wood, slick. So where we built that little base on the bottom of the toolbox, this is now where it slides in. It's going to slide in on top of this. Then I'll put a little piece of flat bar on the side that'll kind of like keep it from getting cockeyed, and there'll be a little lip in the back, so you just push it all the way in and it'll stop. And that's what'll hold it right in place. That's where we're at. So I just got to weld out this. Got to get weld on the inside, all around, and get this thing dialed in. But yeah, I'm kind of like moving ahead, because if I show you every cut and every weld, it's just going to be too time consuming. Alright, so here it is, guys. It's almost done. I see I've got a couple spots that I noticed where I didn't weld it. This is what we got. So the door, toolbox, door, and this is what the frame looks like, and I'll show you exactly what it looks like going in. And the only thing, I think one of the few things you didn't see me do is I installed this piece on the top. Now, I'll explain why I did that, and I'll show you how I did it. I put some like hex bolts down through the center, so I had to drill this one out larger and then do the hole through it, 1/4 inch. So this piece is bolted right to the toolbox, and I put my hands up underneath to nut it. So what this does right here is it's kind of like a filler piece, so that once the toolbox is slid out an inch, then it has another about 3/8 of an inch play here, and the same on the bottom, so that it'll make getting the toolbox in and out. Remember I said I need this toolbox to come in and out easily in case we ever got to service stuff in behind it, which I think we can get, like I said, around it through the cabinet, but I just want to make sure that I can do it. So this is what it looks like. Super straight. Everything's nice and square. Let me set it up on a stand, and I'll show you how the toolbox goes in it. So like I said, I wouldn't want to take this in and out often, but if I have to, I can. And obviously this would be bolted down into the trailer, so this bulkhead wouldn't be flopping all around. I'm working against myself big time right now. Not too shabby, huh? There'll be a door underneath that's removable. It'll just be a removable panel. So now you can kind of picture if you had, you know, a winch that you wanted to mount up under this, then you could just pull the panel out. The winch would be concealed when you're not using it, kind of hidden. But you can see how tight everything fits. All the gaps look nice and even all the way down through everywhere. Just looks like it was bought that way, you know. These are just red stickers, they come off. So. But yeah, here it is. Now I just got to build the doors, which that's not going to be hard. So this was pretty much the hardest part to do the whole project right here. So yeah, I am super happy how this came out. Wicked happy. Alright guys, I'm going to stop this video here. What we have left to do on that rack is basically build the doors, and I want to make the doors one episode in itself because it's going to be building the frames and then covering it with sheet metal and then putting on hinges and hanging it. So that's going to be an episode all in itself, but I figure I would use this opportunity to talk about price and are we saving money and how much, if any, are we saving. So as I mentioned earlier, I bought 3 pieces of this 1x1 tube, and it comes in 24-foot lengths, and it cost me $204. I'm going to use every bit of that tube to build what we built, and I'll have 4 feet left over. I still got to put a top on this, and I still got to build the upper cabinets. But for now, let's just talk about the lower cabinets. So for material and aluminum, I've got $204 in it. Then I got a funny story to tell you about this toolbox. You come over here and you can see it's got kind of like some nicks here, some scratches and scrapes. It's got a ring where somebody set a coffee cup on it over here. But the face of it looks really nice, right? No issues on the face of it. This was a floor model up at Lowe's. So I'm looking at the toolboxes at Lowe's and I'm kind of milling around, not really knowing what I want, but I know I don't want to spend a whole lot of money, right? So I found this toolbox. It listed for like $160. At the time, it didn't have a price tag on it. So I went and got one of the associates, told him I'm looking to buy a toolbox. Can you get someone? Well, a manager ended up coming over, and I explained to him there were 2 different toolboxes I was looking at, and I wanted a price on both of them. After he gave me the price, I leaned towards the one that we currently have, and he said, I've got a deal for you. If you apply for a credit card today, I'll take 20% off your order. Well, I never do those deals, ever. Generally, to save money, I never will. I have one credit card, and I use it for everything. I use it just like my debit card because it protects my debit card. That's just how I choose to do it, and I pay my credit card off at least 4 times a month because I run everything through that credit card. A credit card company probably hates me because they make nothing off me on interest. But anyways, that's besides the point. So I looked at it and I pointed out those damages that I just showed you. And I said to him, well, if you can sell me this for half price, I'll do the deal and I'll apply for your credit card. So it's not like the old days, guys, applying for credit where you go somewhere and you fill out an application. He literally asked me my date of birth, I handed him my license, and I gave him my social security number. He didn't even ask me if I had a job, I was amazed. And I made that comment to him. I said, so for all you know, I don't have a job or anything. He goes, yeah, well, if they give you credit, they give you credit. So they gave me credit, and within a few days I'll get my card. But the good thing is, on select purchases going forward, I'll get 5% off when I do purchases there. My wife and I are looking to do some home improvement, so that'll come in handy because my credit card only pays me 1.5%. So financially it makes sense. If I use that card to shop at that store, I'm going to save more money. I'm going to get 5% instead of 1.5, and I'll just pay it off the same way I would using the other card, and it only dinged my credit 4 points. So so that story is that I saved about half price, which leads us to where we are now. So all in all, in this project, I'm in it, let's call it $200 for aluminum for the bottom cabinet and $80 for the box. So I'm looking at $280. I've got 4 hours in this. This is why these cabinets cost so much money, because it takes time to build them and the overhead to do it. So at a minimum, you're going to get $100 an hour. So there's $400 just in labor alone. And now you're up to $680. If you count your labor as time, which you should if you're going to bill someone for it. If it's for yourself, you can call it sweat equity, however you want to do it. But $680 is what I'll have in this bottom cabinet. And they're definitely probably, I'm guessing, $1,500, I don't know. They're a lot of money. I priced out a whole upper and lower set, very similar to this, and it was several $1,000s. So yeah, guys, that's where we're at. I think we're going to have a really nice looking product when we're done. What you didn't see a lot of is me struggling in the workshop. This table is really nice when you're building small stuff, but my shop is just so tiny, guys. I know I get a lot of comments, I love your shop, I love your shop. It is very cozy, it's quaint here. but it is tight. And, you know, moving something around that's, you know, 7.5 feet long is difficult in this area, especially how I have stuff set up with my bottles at the edge of the table. And someday down the road, this entire top is coming off this pneumatic table, and I'm actually replacing it with a 3/8 plate. And you'll say that's heavy. Yeah, it's heavy, but the material that's on it now, 1/8 inch that's on it now, so it's fairly thick. And I'm going to take it all off and replace it with 3/8 plate. And this is rated, I think, for 1,500. So it'll easily do that and still lift a motorcycle. I probably won't have that extension on the end of it, but then it'll just be real nice to have a pneumatic, solid working surface that I can lay something out really big all the way around without having to do like one corner and then rotating it and doing another corner, because that's how I did this project here. But that's it, guys. And if you're wondering about any of the tools or any of the things that you see me using, I'll have links down below. A couple of the things that I didn't mention in this is that with MIG, you always want to push it when you're doing aluminum. Occasionally, I try not to. You can pull it. It can cause problems because you're not getting the coverage gas on it that you should. But as a general rule, you should always push aluminum MIG. But as with anything in life, you can't have any hard and fast set rules, because if you do, then you're going to box yourself in. Sometimes you just got to do what you got to do to get the job done, even though it's not the professional way of doing it. And I used spool gun with this. You could have easily used MIG, as I've shown you in that video before, and that would have worked just great as well. The only problem with that is I wanted to run 4043 wire, and it just does not work good running 4043 wire in a long MIG whip. It's just too flexible, and it tends to bird's nest up inside the machine. So I want to thank you guys for watching. I want to thank you guys for tuning in. There's new videos every week. So until next Friday, I will see you guys then. Take care, stay safe, God bless. See ya.